And just in regards to transcendental functions, we're talking about sine, cosine, tangent, e, natural log, those type of functions. So remembering and how to do those derivatives becomes very important. But more importantly, the process of all of these is the same. As long as you understand and work with the concept of the chain rule, the differentiation of these problems is much the same. Now, of course, afterwards, when you take the derivative, how you solve for the function can look a little bit, the answers can take various forms in terms of how you go about solving your algebra. So I hope to give you some tips in terms of how to do that. All right, so let's just break out into some examples. One of the examples I really like that I enjoy is the problem sine of x plus y. Um, equals 2y squared, something like this. This is an implicit function. Now, of course, all the polynomials are still going to be hanging around within the problem, but now we have this introduction of a transcendental function, sine of x plus y. I even think you might see it on your homework. And what do I do now? Oh, sorry. In all these problems, we're going to find, in these problems, find dy dx. And actually, instead of calling that, let's call this example A instead. Okay, so find dy dx, and here's example y. So what do I do? What do I get? Can you even hear me? No product. There's not a single product in this problem.
Chain rule.
It's chain rule, good.
So cosine.
Cosine of
X plus y.
x plus y.
And you gotta do the outside. So you gotta do the baby.
Correct.
Times 1 times
Not times.
dy dx.
Not times.
Oh, plus dy dx.
Yeah.
Okay, and then you have equals 4y dy dx.
dy dx. So this problem only has one chain rule part. It has the transcendental function of sine with a chain rule and the functions inside it. Now, when going about solving this problem, there's a lot of different ways to do this algebra. Okay, there's two main ways about going about solving this problem. Now, well, actually, never mind. This one is interesting because this one has a dy dx over here on the left, and it has a dy dx over here on the right. If the dy dx wasn't there on the right hand side, then I could have just divided by cosine of x plus y. That's traditionally the easier problem. But because that's not there, I have to when I have the variable I want to solve for on both sides, I need to make sure I isolate that variable. So I got to expand in this case, which gives me cosine x plus y times 1, which is just cosine x plus y, plus cosine x plus y dy dx equals 4y dy dx. And what do I do now? And we need to get some participation in here, not just from Mariana.
So wait, okay. So the first part would be negative sine.
Cosine, you mean?
Why would it be cosine?
Where are you getting sine?
Where it says cosine x plus y, aren't we finding the derivative?
We've already found a derivative.
Oh, I'm sorry. Pardon.
Yeah, we already found the derivative. We've already differentiated. When you see the dy dx there, we'll talk about the second derivative and what that means and does, but we've already differentiated. Now it's just algebra. Now we're just doing algebra. Actually, once we get over here, we're just taking care of algebra now. So what do I do?
You want the dy's and dx's on the same side, and then you move the cosine x plus y to the other side.
Yeah. So just algebra. There's nothing fancy about this. We're just doing algebra. Whatever you do to one side, you do to the other. And that gives me cosine x plus y equals 4y dy dx minus cosine x plus y dy dx. It's the same process, all right? The only thing that gets people like, oh ma, is that you have a lot of anxieties that because the function is different. What do we do now? Same algebra processes we've been doing this entire time. It's the same type of problems that you've been solving for implicit differentiation. Same exact step that we do every single time we get to here.
So wouldn't we divide both sides by 4y minus cosine x plus y?
So Farida likes to jump, and that's actually technically that's what I do when I do my problems, and that comes with a lot of practice. But for notes purposes, I'm going to show the factoring out of the dy dx.
I was going to say factor. Okay.
Yeah, so that's what she's done, but she knows that when she factors, then she gets to here, and then she's going to divide by the 4y minus cosine of x plus y. And it's the same thing. I mean, that's once you do enough of these problems, you know that the dy, technically, when I do it, when I move everything here, and I get to here, and I know that I've moved all the dy dx's to one side, I automatically go to the factoring of the dy dx because it's just what makes me feel comfortable, and I know that that's what happens every single time I do these problems. And so we get dy dx equals cosine x plus y all over 4y minus cosine x plus y. So really, the only difference in this problem was that there was a sign in the beginning problem. Everything else after that, once you get to this step, this first step in here, after you've done the implicit differentiation, I want to note that all of this is just algebra. And that comes through practice, practice, and more practice. All right? Identifying, now, going from here, that was the only calculus that was done on this entire problem, and everything else was algebra. B. 1 plus natural log of y to the third power equals x times y. Find dy dx. All right. What do I do? All right. I use the chain rule. And how do I do that?
So is y is lady, so is that ln?
No.
No, this one is 1 plus ln y.
No. It's chain rule, so let's apply the chain rule.
So it's 1 over.
No, the first part of this problem has nothing new. The first part of this problem doesn't even deal with the natural log of y. Okay, what do we get?
3, and leave the baby alone. To the second power.
There you go. So that is the chain rule part. So when you say chain rule, and this is why I also when I say chain rule, yes, that's right, but that's not necessarily means you're right because you can say chain rule and not know how to apply the chain rule. So the chain rule here is the 3 comes down, the baby stays. That's what the chain rule process means. And then subtract by 1, of course, because we're doing it multiplied by the derivative of the baby, which gives me what?
Is it 1 over dy dx?
No, close. It is a 1 over.
Is it just y?
It's 1 over y.
Oh, dy dx?
Times dy dx. All right.
And then equals 1 dy dx on the other side?
No.
I saw xy dy over dx.
There's no over, no.
Y?
Yeah, well, let's
Plus.
do it's a product rule. So recognize this as a product. And then when you think product, I always like to do it like this. In my mind, this is what I'm seeing in my mind. I'm going to do brackets representing the derivative, parentheses representing the function. You don't have to write it out this way, but whenever I see a product, I'm always thinking bracket parentheses plus bracket parentheses. It helps me visualize what's going on with the derivative of those functions. And so, and I heard Ariana give me, she just said 1. She just said y because it was 1 times y.
Plus.
Plus.
Oh. And then dy dx times x.
So product rule. And it's okay to make mistakes. It's okay to, I have much more respect for those individuals who are coming out and saying something, and while it's not the right thing, that's why you're learning from it, than those individuals who are not doing it, saying anything. I don't even know if you're awake. And now it's time for algebra. This is a tricky algebra 1. What's my play? What's my play? Visually, I like to look for all the dy dx terms. That is all one dy dx term.
So what did we move over x dy dx to the right side?
To the left side.
Oh, that's what I meant. I'm sorry.
Yeah. So we're going to move this over here. So we're going to subtract dy dx. I like to say it as x dy dx. Subtract x dy dx. And then I'm going to clean up the other part. So when I clean up the other part, I get 3 parentheses 1 plus natural log y squared over y times dy dx minus x dy dx equals y. And I know my answer is going to look a little funky, but it's fine. I'll factor out the dy dx. 3, 1 plus natural log y squared over y minus x equals y. So dy dx equals y over 3 parentheses 1 plus natural log of y quantity squared minus x all over, oh, sorry, that first part over y. And if you wanted to clean this up, we could multiply by y over y, giving me y squared over 3 natural log 3 parentheses, sorry, 3 parentheses 1 plus natural log of y squared minus xy. This is also a proper answer, but that one right there is more than fine, especially on a free response. And in reality, you're not going to see a problem, most likely, that's going to be this ugly on the free response, especially with the natural log y's. I really haven't seen those pop up on the multiple choice even, or the free response. But the process of understanding what you're dealing with and how to do the algebra is worth much more. It's the practice from doing these problems that's way more important than than being like, this problem is going to be on the AP exam. Example. Sine of y equals e to the y times x. What do I do? Okay, so cosine of y times dy dx equals.
Okay, and then you have your e to the power y, times your, wait, is this a product rule?
Mm-hmm. Let me switch the color. Let me switch the color up real quick. Okay.
Okay, so it would still be times dy dx times x.
Mm-hmm.
Okay, then you have your plus, and then you have your e to the power y.
Well, I like to do it as the 1.
Oh yeah, 1 times e to the power y.
Yeah. I mean, in the end, it's going to be the same thing, but just for the purposes of writing our notes, how to do it. So it's a product rule. So I mean, now this one introduces the exponential function. Remember, copy paste. So the derivative of e to the y is e to the y dy dx. Copy and paste times the derivative of the baby, and the derivative of the baby is dy dx. All right, what do I do next?
Well, the dy's dx on the same side.
Mm-hmm. So I get cosine of y dy dx minus x e to the y dy dx equals e to the y. And the final step is basically the same thing we do every single time. Factor out that dy dx and then divide. Move, factor, divide. Move, factor, divide. Always the final steps. X equals e to the x times y. Find dy dx. What do I get?
Is this the power rule? Like, what is this?
You're just what's the derivative of x? It's the easiest derivative of all functions.
Oh, x is 1.
Okay. Just 1.
But what's the rest? Isn't it gonna be equals e to the x plus y
Times
dy,
y.
times y dy dx. Or no?
It's time x and y.
Oh, that's the product.
Yeah, I think so. So we should hit down the x to y.
No.
When that no.
So we got to differentiate. It's product rule.
Y, 1 times y plus dy dx to the x.
There we go. Got to make sure and here's the truth about this. Any mistakes in terms of not getting this and your entire problem's wrong on the multiple choice question. Any mistake made in terms of not following these processes of the derivative of e to the xy is e to the xy times and getting the product rule will not get you any credit. You don't get when it comes to processes like that. I mean, there's always other built-in problems, but if you're not doing the product rule and doing the product rule correctly, or applying the chain rule and trying to chain rule correctly, one of the biggest serious things you have to realize is that you're not going to get credit on the exam. So we really got to make sure that we hammer these down. Now it's just algebra. There's actually multiple ways of doing this problem. What's the easiest way to do about it in doing my next step? There's only a single dy dx term. So what do I do?
Do you subtract?
No.
Oh, it's gonna be x dy dx, and then
No.
I can say either you.
There's no derivatives. We've already done derivatives. Yeah, so
you divide by your e to the power of x times y.
Yeah, so there's two options we could have done here. We could have distributed the e to the xy to both terms. Remember, this is algebra now. You've already done the other work, so now it's just algebra. So there's no such thing as chain rule or product rule or differentiations. It's just algebra now. You could do that. I think that makes the problem a lot harder and longer. So the best way to do this is, since there's only one term that's dy dx, you just solve the problem like you do PEMDAS, reverse PEMDAS. You work from the furthest thing away from the dy dx and then come back. So the furthest thing away is e to the x times y. So now I get 1 over e to the x times y equals y plus x dy dx. I can subtract y from both sides. 1 over e to the x times y minus y equals x dy dx. And therefore dy dx equals 1 over e to the x times y minus y all over x. Algebra. Everything in blue is algebra. So after I take my derivative, which I've done in purple every time, I then try to locate my dy dx terms, assuming that I've done my differentiation correctly. Then once I found that, I plan and how I'm going to do the algebra to get the dy dx's and to solve for that dy dx. New example. R squared plus cosine squared of theta equals 1. Find dr d theta. All right, new variables. That's all it is. We already had this as our own homework assignment. We don't always have to work with x's and y's. What do I get to start off? What is that?
2r.
2r, yeah.
Times dr d theta.
Perfect. Next one's a tough one.
Plus,
Okay, so
no, it's not negative sign.
No, it is a plus.
And shouldn't it be, would it be 2, or would it be, wait, cosine? Isn't it -2 sine? Oh,
No.
okay. 2 cosine of theta.
Oh, sorry.
Okay.
I forgot I was going to do this in a different color. Just doing it in a different color, that's all. So 2r dr d theta plus, now remember, this here is the same thing as cosine of theta squared.
So it's just 2 cosine of theta parentheses. And I gotta do the times the baby, so it'll be negative sine of theta.
There we go, negative sine of theta equals 0.
Yeah.
And now we just do some algebra. Once again, I recognize where my dr d theta is. There's only one term. So I'll leave that by itself. So I get 2r dr d theta equals 2 sine theta cosine theta, which is technically sine of 2 theta, but we're not going to use those type of stuff. And therefore dr d theta equals sine theta cosine theta over r. And for a final example, s squared r equals 4. Find dr ds evaluated at r equals 1.
This is a product, right?
It's going to be a product.
So the first part would be 2s multiplied by r plus dr ds multiplied by s to the second power equals 0.
Okay.
Now do we move over the dr ds to the other side?
You could, but I do not recommend doing any of the solving for DRDS.
Would you minus 2SR?
I do not recommend doing that because look at what the question is.
So you just substitute R of 1?
Yeah, so that's 1, but wait a minute. We're missing this S.
So wait, don't we have to find the 1 first in the original equation?
Yeah, so we have to plug in 1 into the original for r, and that gives me s squared equals r's, or is 4. So what does s equal?
2. Plus or minus 2.
There you go, plus or minus 2. So that means there's 2 answers here. So we're going to have to do one when s is equal to 2 and when s is equal to negative 2. So when s is equal to 2, I get 2 times 2 times 1 plus dr ds times 2 squared equals 0. And on my other side, I get 2 times negative 2 times 1 plus dr ds times negative 2 squared equals 0. I'll do the left-hand side first. That gives me 4 plus 4 dr ds equals 0. So dr ds is equal to negative 1. And the other one, I get negative 4 equals plus 4 dr ds equals 0. So I get dr ds is equal to positive 1. Today was about practice problems. Hopefully you're taking the time to do as much of these practices along with us while we were doing them, attempting them maybe beforehand, thinking about what you're going to do for your next step. It takes a lot of practice in terms of doing these problems. I've been doing them for years. I can do them and recognize what I've been doing them because I've done thousands of these problems. And it comes by just through practicing and doing as many problems as you can. And like I said, hopefully you've seen that what we just did is nothing new. It's what you've been doing for the last week in terms of implicit differentiation beyond yesterday's review lesson. It's just implicit differentiation. The only thing that we did here is we added in these other 3 functions that we hadn't seen in a while, but the process and everything is the same. And then when you work the algebra, you work the algebra the same way you work the algebra with the other material. Your homework is a handout. It's posted on Google Classroom. It is now 8:49. I'll see everybody tomorrow.